So what's up to everyone? I'm gonna wait for some people to show up, but we are in week 12 doing math help from Algebra 1 all the way through Calculus 2. So if you have really long problems here, you could email them to vinteachesmath@gmail.com. That email is listed right at the top of the stream here. So you can do that. But I will wait for some people to show up for us to get rolling here. But maybe while I wait, I will pick a random calculus question to look at here. So let's see. Maybe let's get a interesting one. All right. How about solving for values of a and b that will make a function continuous and differentiable? All right. So if I have f of x, and let's say this is equal to, let's take a look at 3 minus x. So from here, x less than 1. And then we have ax squared plus bx for x greater than or equal to 1. So for this, we want to solve for a and b so that this function is continuous everywhere. Now, what we could do is we could treat this in a situation where we could look left side and right side. So we could check out the left side first. And this is like purely like an algebraic solution. So the left side, and it's going to be x is approaching 1 on the left side. We would use the x less than 1 piece. We have 3 minus 1 is equal to 2. And then on the right side, when x approaches 1 from the right side, we substitute in 1 and we'll have a plus b. So what we need here is we need a plus b to be equal to 2. For this function, we want f of x, we need f of x to be, so we want, let me just make that actually just better altogether. We want f of x to be continuous and differentiable. Okay, this is our goal. So what we're going to do is we need a plus b to equal 2 because this will guarantee that the limit exists and that our function is continuous at x equals 1. Okay, just know definition, the fancy definition of continuity is this one here. The limit as x approaches c of f of x equals f of c. So this is for continuity. We need to show this. But now for the next stage of this question, zoom out a little. What we could look at is f prime of x. And for f prime of x, we have the derivative is -1 on top, and it's 2ax plus b on bottom. Now, what we have to say for now, x less than 1, and now just x greater than 1, because the reason being, the derivative is not going to be defined for any random value of a and b. We have to actually solve for that. But we're going to repeat the same process. So left side and right side. So now x is going to approach 1 on the left side, and it's just fixed at -1. But when x approaches 1 on the right side, we substitute in 1 for x, we would have 2a plus b. So we need -1 to be equal to 2a plus b. So now what we have is a system. We have a plus b equals 2, and 2a plus b equals -1. So now we go forward with this. So these questions take up quite a bit of space. All right, so 2a plus b equals -1. And this one here, what I could do, I'm going to multiply everything here by -1, and I'll have this. So now when I add these equations together, these terms cancel, and we get 1a equals -3, because 2a minus a is 1a. So this gives us our value of a, and then our b value we could get by plugging in. So if a is -3, we have -3 plus b equals 2. That tells us b is equal to 5. All right, now what I would do for this is I would double check that this actually does form something continuous and differentiable. So if I wrote out f of x, and I have 3 minus x, x less than 1, and then we have negative 3x squared plus 5x, because we found a and b, x greater than or equal to 1. And my little mental check here is if I plug in 1, I got 3 minus 1 is 2, negative 3 plus 5 is also 2. If we were to sketch this, 3 minus x is a y-intercept of 3, and it has a slope of negative 1. So that's coming this way. So slope of negative 1, whereas this one, oh, I'm sorry, and we're going up to x equals 1. So this is heading here towards the point. This is heading towards the point 1, 2. And I'll leave it open for a minute, but this one is going to pick up right where the other one left off. And negative 3x squared plus 5x, if we plug in 1, that brings us here. If we were to plug in, let's say, 2, we could see here for this one, this is going to be a little bit annoying to graph, but it looks like if we take out an x, we'll have negative 3x plus 5. So this one would have a root at x equals 0 and a root at, looks like 5/3, which is 1 2/3. So that's like over here. And if we look here, this thing is dropping. So I imagine the vertex is like over here, but then it like starts to drop like this. So that slope is picking up where the other one left off. And that would be our solution here. Okay, I can double check this. So let me just check the trusty answer key as soon as this thing unfreezes. But to anyone who just joined, like hello. And if you got any questions, let me log into my my Vinteaches Math email so I could see if anyone's got questions. But otherwise, you know, you could send your questions right in the chat as well. But welcome to anyone just joining. Let's see. That question is, all right, so there was no answer key for it, but that seems legit. It seems right. So I'm happy with it. All right. Yeah, the other possibility here would be that this stuff works out positive and changes into a smile. But, you know, double checking that next part. If I had f prime of x, like I really want to check this. Now I have a slope of negative 1, negative 6x plus 5 for x less than 1, x greater than or equal to 1. And if I plug in 1 here, I get a matching negative 1 slope. So I'm feeling pretty good here. Oh, Vlad, how you doing? Hello. Nice to have you on board. If you're here for, you know, are you in Calc AB? Because if you're in Calc AB, you could always email any questions, or if you're just saying hi, then hello. But I'm just going through random calculus questions until someone requests something specific. Most of my students are expecting 8:30, but I wanted to get an early start because, yeah, just tired today. But yeah, I hope your school year is going well. All right, let's see. So until I get an actual question in the chat, I'm going to keep doing my own questions. But Vlad, I appreciate you being the first one to jump in here. All right, let's see here. We'll get a good question. All right, saying we got more viewers. So hello to anybody just joining. It's still early. Cool. All right. So then, yeah, I'll do your question next then, Vlad. So that works out. Make sure I am in. Okay, here it is. MVT. All right. So this one, let me just make space. Oh, wait, over here. All right. So a car speedometer registers 50 miles per hour. So I'll just kind of like, I don't know why I'm thinking number line, like 50 miles per hour. And as it passes a patrol car station 4 minutes later. 5 miles from the first. Oh, okay. This is a nice question. All right. So this one here, let me see if I get a little screenshot of this. So let's see, just so that it's visible to everybody. So let's see. I think something like this. I don't know if it's from a textbook. It might get flagged if I screenshot it. So I'll just like kind of paraphrase here. But so you have a speedometer, 50 miles per hour. So it passes the marker like that's over here. So this is like, I don't know, this is the car. It's my great artwork. Okay. So there's the car, 50 miles per hour. 4 minutes later. So, okay, so 4 minutes go by. So 4 minutes later, and it gets like marked again. So 4 minutes later, the car passes another marker that is 5 miles. Sorry, so this is 5 miles. Okay, 5 miles from the first, and the driver notes that the speedometer registers at 55 miles per hour. So this is like their instantaneous rate of change. 55 miles per hour, 50. Can the highway patrol use MVT to prove that the driver was exceeding the speed limit of 70 miles per hour at some point between the 2 mile markers? Okay, so it really depends on here the average rate of change. So this person is going 5 miles in 4 minutes. But one thing is that these are in miles per hour. So just know 4 minutes, if I do times 1 hour for every 60 minutes, this reduces to, was that going 15 times? Yeah, 4 over 60 is 1 over 15. I mean, if I just had a check, I mean, I could always just do this on the side because I could get a calculator, but I'd rather just do this here. If you divide, that's 1, 2, yeah, 15. So 1/15. So this is 1/15 of an hour. Okay. So what that tells me is that this driver went 5 miles per, instead of, I could say 5 miles per 4 minutes, or I could say per 1/15 of an hour. Okay. So this is like the idea. Just know like the rate is equal to like the change in distance over time. Okay. So your rate is change in distance over change in time. So this is like your average rate though, because this is like, yeah, this is like instantaneous, these, but the average rate of change. So we're finding right here, this is the average rate of change, which we could abbreviate with AROC. Okay, so now just do the math. This is 5 times 15 over 1 if you keep change flip, miles per hour. And this is equal to 75 miles per hour. So the average rate of change is this here. So what that tells us is if they want to use MVT to prove the driver exceeded the speed limit, they definitely did. Because the only way to have an average of 75, you would have to have some values that meet at least 70. So I would say here that MVT can be used to prove the driver exceeded 70 miles per hour. And how do we know? Because by MVT, if we had to really write a thorough argument, by MVT, there will be a time, let's say from like 0 to 5 minutes, where the instantaneous rate of change, so that would be like the, I don't know, like the velocity of the car is equal to the average rate of change. And the average rate of change was 75 miles per hour. Okay. Now, one thing, to use MVT, you have to say your function is continuous and differentiable. But I think here we could assume that cars are driving continuous and differentiable, like meaning like their speed is not like skipping anything. It's like just going, like the velocity is going continuous, whether or not they step on the brakes. Okay, but that's the idea, is the average rate of change is how much distance do they cover over time, but the instantaneous is how fast they're driving. Like 50 and 55 is like kind of a distraction. You don't really need that information to go forward with this. All right, but yeah. So good question though. U sub, yes. Grades aren't doing so good, but working on it. Yeah, I mean, I would say, so at Vlad, it's just, honestly, it's practice, but there's two kinds of practice for calculus. You're either just going to do a ton of techniques. Tomorrow's test is just indefinite. So plus C 9 times. And then the meaning of life question. So what's it called? Oh, sent over a question. So yes, I can do more questions, but you got to practice the questions that involve, what's it called? You got to practice questions that are just technique. So at Vlad, you just have to be like, let's say chain rule. You got to be really good at chain rule, and you got to be able to just do that in your sleep. But then like what we just did, the mean value theorem, you got like, that's more conceptual. You got to know theorems inside and out. So like not only be able to recite them by memory, but be able to say them, draw them, and use them. Okay, there's like a lot of ways you have to be good at these theorems. But it's, the thing is, if you try to just do a ton in one day, it's better to do a little each day. That's like a less stressful way to learn this stuff. All right, it's intimidating, but you could totally do this. All right, so I will do also some indefinite integrals. I could do U sub. I got a question 80 from Leet. Let's see, use trig identities and blah, blah, blah. Find the trig value in the specified quadrant. Oh, okay. So 80 is cotangent of theta equals -3. And we're looking for the quadrant 2. So we're in quadrant 2. And so using trig identities, we want to find the trig value in the specified quadrant. Okay. Oh, we want to find sine theta. So find sine theta. Okay. Oh, yeah, these questions. All right. So this. First, know this. ASTC. So the fun way of remembering it, you could say all students take crack. You could say all students take calculus. There's, plenty of fun ones. But what you need to know is that in quadrant 2, what that means to me is that sine is positive in quadrant 2. Okay. Also, we could say, cosecant, the reciprocal, is positive in quadrant 2, but just those two functions. All right. That's how, why cotangent is already negative, because cotangent would be positive in quadrants 1 and quadrants 3. So what I do with this information, first I would switch this to the reciprocal. I would look at tangent. Let's color code this. If cotangent theta is -3/1, then tangent theta is the reciprocal -1/3. But what you also need to know is the basics, SOHCAHTOA. All right, so what this tells me when I hear this, I'm like, all right, tangent theta is equal to -1/3, but in general, it's the ratio of the opposite side to the adjacent side. So now when we piece all of this together, let's say we draw out this XY axis. We are going into quadrant 2, okay? And I'm going to draw our triangle here like this. All right, so there's our triangle. And the angle theta is here. All right, this is going to act as our reference angle. All right, so I want to treat this as a reference angle. And the definition of a reference angle is that it is the positive acute angle between the terminal side and x-axis. But one thing I should specify, technically this, let me just erase this part, because I'm teaching trig in like a month to my precalculus group. Technically, this is our angle, but our reference angle is this one here. It is the positive acute angle between the terminal side. So that would be like if I spin here from standard position my full angle is theta, but the reference angle is the positive acute angle between the x-axis and the terminal side. So that's this angle here. So we use that, and we can see here that opposite of the reference angle is going to be 1, and then adjacent is going to be 3. All right, now notice like the negative was attached to this, but notice here like I'm going to the left 3 and I'm going up 1. All right, so that's how I know like this ratio is working out negative in a way, because in quadrant 2, you know how like your x values are negative and your y values are positive. All right, so like that's how I know like this is going to come out negative. That this is not like a true 1 and a 3. Going to the left 3 is like going negative 3. So that's why this is working out negative. But now how does this help us? We use Pythagorean theorem to get the hypotenuse. So if you say 1 squared plus 3 squared, it is equal to the hypotenuse squared. I'll just call it x. Actually, x is a bad letter because that's the x-axis. I mean, I guess I could use c like this. So this would be 1 plus 9 equals c squared. Take the square root. And this tells us c is equal to square root 10. So this hypotenuse is square root 10. So then what we do with this, now we're just trying to find sine of theta. So sine of theta, we could just use the reference angle is equal to the ratio of the side opposite, which is 1, over the hypotenuse, which is radical 10. All right, so that would be your solution here. Now, one other thing I would mention, let's say they wanted cosine. If they want cosine, notice we are in quadrant 2. Cosine, if you look, is negative in quadrant 2. So this would be equal to negative cosine of our reference angle. Okay, and our reference angle is here, and using this, we would have negative, and then this would be 3 over radical 10. Now, one thing you could do with these questions to check is, let me open the calculator. So you can check these with the calculator. So we will do that. Let me just adjust the stream here. The display, press that a second, because I want to make space for the calculator. Okay, so here this is, yeah, maybe I'll do it like this. Yeah, because I want to be able to look at both simultaneously. All right, here we go. So display, capture back on. All right, here we are. All right, and that doesn't help a ton. All right, so I want us to just point out, we started with, and it doesn't matter if I'm in degrees or radians for this, but we started with tangent theta. So this part, tangent theta is equal to negative 1/3. So if I do tangent inverse of negative 1/3, see, that gives me this angle, negative 18 degrees. But that, if I treat it as my reference angle, let me just do that. If I do tangent inverse of 1/3, that tells us our reference angle is 18 point whatever degrees. So then if I want to be in quadrant 2, I do 180 minus that reference angle. So that's the full angle theta. And I'm going to store this as the letter A. All right, so now our goal was to find sine of theta. Okay, so sine of that angle is this. And if I do 1 divided by square root 10, that was our answer. You see, we get the same exact thing. And now, like if I want to check, cosine of that angle should be negative 3 over radical 10. So if I do cosine of that angle, which I saved as A, that should be, don't get old, I already forgot, negative 3 over radical 10. Okay, so yeah, that's the trig stuff. All right, so I hope that helps a bit. So that was for LEET. Yeah, trigonometry, this topic is, it takes a while to get good at. All right, it's not super easy, but you just got to be patient and, you know, do a lot of examples, but just know the reference angle stuff is very big. All right, knowing, like the last thing I'll say before I switch to calculus is that your reference angle in quadrant 1 is equal to your angle theta. Okay, like in quadrant 1, whatever angle you spin, Like this angle theta is like the same as your reference angle because they're both positive and acute. In quadrant 2, your reference angle is equal to 180 degrees minus your angle theta. So yeah, like let's say my angle was 150. Like if I had theta equals 150, my reference angle would be 180 minus 150. So I'd have a 30 degree reference angle. And if we drew that out, see 150 is like this. You could see the 30 degree angle is the angle between the x-axis and the terminal side. Okay, in quadrant 3, your reference angle would be equal to theta minus 180. And then in quadrant 4, your reference angle would be equal to 360 minus your angle. And I only know this so well because I know the definition of reference angle. All right, and that's the way I teach, is like advanced basics. Like just know the basics really, really well. And then I haven't done these questions in like close to a year, but I could summon them because like I get the basics. All right, that's what you want to aim for. All right, so integration by parts, U substitution was requested. All right, so we could do that. U sub. And let me grab a U sub question. All right, how about, let me see. All right, something like this. So let's say we had something from the packet, like something like question 12, x over, and if I had 1 plus 4x, oh, there was a square here, make that neater, and then this squared, and then dx. All right, so use substitution, then I'll do integration by parts and inverse trig. I would say yes, like don't, you'll see what I mean when I say simplify. I'll be like, you know, because we're not necessarily adding numbers, you know, so I'll say simplify. Like if you have to do power rule tomorrow, like this, like don't do this, like, oh, this is x to the 1 plus 1 over 1 plus 1, you know, plus c, like that's gonna be annoying to look at. So like, please do 1 plus 1. That'd be nice if you could do that. So yeah, I would say simplify, but it's not going to be anything absurd. All right, it's not like you have to add like 20 fractions together. All right, so here what we have is, oh wait, I'm sorry, I lost my train of thought. So u sub, we're doing u substitution. So u equals 1 plus 4x squared. That's the inside. And then du is equal to 8x dx. And then divide by 8x. You get here. And then dx equals du over 8x. So now we could substitute. So we've got x on top over, that's going to be u to the second on bottom. And then dx is du over 8x. And the x's will cancel. Okay, these are going away. And now I would take the 8 out from the denominator as a 1/8. And all right, don't do this. So here comes the bear trap. All right, please don't do this tomorrow. This is going to be a common mistake. Don't like this, like, you know, bear trap, you know, and then cue the bear sound. I didn't like somehow get the bear sound effect button in this thing, but maybe by week like 112, my technology will be that much better. If the channel really grows, yeah, I'll just keep upping it, like for sure. As the channel grows, like I'm gonna just keep upgrading everything. Like if, let's say I was making some crazy money, like I would just spend like, I don't know, ridiculous money on decorations. So it's as the channel grows. Speaking of which, the channel reached 18,900 before, so 19,000 is in reach. It would be really cool if I could hit 20,000 before the school year is over. Maybe this AP season, if I live stream. I was thinking of doing something crazy before the AP test. I might do a live stream for like, I don't know, like 8 hours or something. Like kind of like how Black Pen, Red Pen, he's like one of my favorite math YouTubers. Like he did that 6-hour integration thing. Like if I did like an 8-hour, I'll just get like a 3-course meal or something, or just pack a lot of sandwiches and just live stream for that long. But we'll see. So then you get this. So power rule, do -2 plus 1, but then you got to divide by this, and then you write your plus c. So then this is like -1/8, and then instead of u to the -1, and then our plus c, u was equal to 1 plus 4x squared. So this is 1 plus 4x squared. Okay, and this, if I simplify, is like -1/8, 1 plus 4x squared. And then plus c. I guess I could distribute that 8. Let me see. Oh yeah, that looks like choice. No, well, in the packet it would be choice C. Let me just double check. This was 12 is C. Yay, it's right. Cool. I'm definitely gonna mess one of these up. Yeah, I think the key door, like, I'm starting to figure it out. Like, I've been on YouTube for almost 10 years, but I did take that little time, but I'm like starting to see the bigger picture, like how, like which videos are getting more views than others. So 20K before New Year's. Vlad, the only problem with that, yeah, in 1 month, I don't know. I'd have to, like, the algorithm would have to be really nice to me this month. The problem is, like, my slowest months on YouTube are December is like kind of slow because of, you know, like Hanukkah, Christmas, and New Year's. Like, most people on break, like, don't want to do math. And July is like super slow because as soon as the school year's over, like, no one's even thinking about math. So that's why, like, I sprinkled in a little bit of chess, but I mean, I think I just have to go really just all in on math. Like, I'm changing the brand all the time. And I think, like, what's going to maybe make it special is, like, that Japanese temple problem. I need to do more stuff like this. So, oh, liate is nice. Also, is liate. Oh, liate. Oh, that was a typo. I was like, oh, did you come up with a new one? Maybe. So I'll do integration by parts. Let me find a question from the packet that has a star. Oh wait, where was it? I could do x cosine x. That one works. Or I can even do maybe natural log x. Okay, this is the nice one. Oh, liate sounds cooler, but whatever. I mean, delta math. Because then I can make the liate joke, you know, like, you know, oh, $5 to take a picture of the board, and then I could buy a liate. So the other one, it doesn't really have a nice lipet. I don't know. I have to think that maybe it has potential. The T and the E are reversed. Honestly, trig and exponential, I guess they're interchangeable because that's the one that loops. Remember the one I did in class where I had to do it twice and then, like, it gave us the same integral to start? So here, like, yeah. Now this liate. So log is our first one. So that's definitely going to be our U term. It is going to be this. All right. Obviously, it's not going to be... like, our dv term is obviously not ln because we don't know what the if we knew what the antiderivative of natural log x was in our head, then we wouldn't need this. Now let's say, oh no, I forgot the formula. Remember, the proof was you take the product rule and then, like, you reverse engineer it. Like, you say, like, all right, the integral of all of these, and then this is like just uv equals u prime v plus integral u prime v plus integral uv prime. So that's why, like, the integral of, like, u dv, like, that's this piece. That's, like, essentially what we're doing. We're calling this, like, u, and this is our dv. So then the integral of u dv is equal to uv minus the integral of v times du. All right, so, but if I forget that formula, I just do product rule backwards. Like, I'm going to forget that formula plenty of times. So the derivative is 1 over x dx. And the antiderivative of 1 is x. The plus c we write at the end. So now this integral is equal to, we have u times v. So that's x ln x minus the integral of, and now you have v times du. Oh yeah, I should mention here, I could call this u prime, or I could call this du. Either way, this is going to give us the same result. Du is probably better, so I'll just use that. Just nicer notation. X times 1 over x is 1 dx. So now this is x ln x minus the antiderivative of 1 is x plus c. What's nice about these, though, if you want to check, just take a derivative. Okay, if you take a derivative of this, x ln x minus x and then plus a constant, this piece use product rule would be 1 times ln x plus x times 1 over x minus the derivative of 1. I'm sorry, minus the derivative of x is 1, and then plus 0. So this simplifies to ln x plus 1 minus 1 plus 0. These all cancel. So ln x checks out. All right, it worked. Exponent rule. Wait, what do you mean exponent rule? I have to see what it means, because like I just say do antiderivatives. I may not be doing anything special. Oh, more people use lipet. Okay, or lipet. All right, I guess I could say goodbye to liate. I mean, I was just, but yeah, for the ones like, look, depending on where you go to college, I would say like the liate is gonna cover like the Calc BC stuff like more than fine. I mean, this is like this is the 3rd year I'm teaching BC, but 8th group that I'm leading to the AP test. But like so far, I haven't run into any trouble with liate. Maybe some colleges, if they ask like really crazy ones, like oh, you don't lipet, like then we'll be in trouble. But I think we'll be all right. 58. Ooh, all right, that one looks wacky. Let's see. Yikes, let me think about how I would do that. I guess 58 is, I'm just trying to think of something creative. So u sub is not going to work. Yeah, that's not going to work nicely. I guess we could do division. My instinct, all right, I don't know why I'm inspired to do this, but my instinct is to transform this into y, and then I'm going to do this. I'm going to write plus 1 minus 1. I always like to try this, and then this. All right, I don't know why I want to do that, but I want to do y plus 1 minus 1 and then minus 1, because this is technically like this is 0, this piece here. So I'm not really changing it, I'm just adding stuff in. And the reason I want to do that is because now this is y plus 1 minus 2 over y plus 1 dy. And now I could break this up. This is y plus 1 over y plus 1 minus 2 over y plus 1 and then dy. All right, some nice, some nice little, I don't know if I would call that, that's like not nice algebra. That's so I don't have to do polynomial division. All right, because I'll show you with polynomial division, like you would have to do like y minus 1 divided by y plus 1 on the side here, and then y goes into y once, and when you multiply by this, and then you subtract, when you subtract, the signs of everything change, and it becomes like negative 1 minus 1 is minus 2, so that's your remainder, 1 minus 2 over y plus 1. All right, so yeah, technically you could do long division, but I like to do that plus minus. That just looks cooler, I think. But remember, you don't get style points. If you feel safer, just do this. Y plus 1 over y plus 1 is 1 minus 2 over y plus 1 dy. Now look, here we can skip u sub, all right, because the derivative of y plus 1 is equal to 1. So it's like if your derivative is going to be 1, that means you could skip the u sub process and just go forward. So now the antiderivative of 1 is y minus 2 times the antiderivative of 1 is y. The antiderivative of dy over y plus 1 is natural log absolute value y plus 1, and now plus c at the end. So that looks like, where are we? Y minus 2 ln. Is that choice A? 58. 58 is A. Cool. All right, so let's see. Oh, so at Xiaolong, when the base is a constant. Oh, I'm not going to do that. When the exponent is a variable added with a constant. Yeah, I'm not going to do. The only exponential that could show up would be something like e to the x based. You know, I'm not going to do anything wacky yet. We'll have a day on those. I'll sprinkle that in, but yeah. But I'll check the messages. Yeah, I'm not going to do something like that. That's an interesting question though, for sure. So that one, yeah, you'd have to, like, honestly, I'll show that on a different day, because I mean I could show you the technique for those, but it's I usually, when I forget an antiderivative, I recreate it with my derivative. But we have to learn. I'm gonna save that for like unit 7 or unit 8. It's either 7 or 8. I think it's unit 8. Unit 8 is differential equations. So just hold that thought, because I would be kind of cheating to show you something from later. But yeah, I kind of teach it in a weird sequence. Oh, you didn't want to do it anyway. Cool. All right. Very nice. So Vlad, extreme value theorem. Okay, so absolute maximums and absolute minimums. So sure. All right, let's think. The extreme value theorem. Let me see if, oh, here's the application. So that's Rolle's theorem, mean value theorem, critical points. I'm just trying to find a question from the problems book. Sketching functions. Why are they hiding? What if I write the word absolute? I'm just going to do control find, write absolute. The book is going to freeze because that word probably shows up 1,000 times. Oh, wait, here we go. Was that? Sketch the graph. No, I'm not going to do. Oh, yikes. That one is like, ugh, pretty horrible. Let me find one that's like not as, that's because that will take up the rest of the time. I mean, I guess I could find one with trig. Sure. So f of x equals e to the x cosine x, and we're on the domain 0 to 2 pi. All right, and let's say we want to find the absolute extrema. So the concept that you need, when you have a graph of something and you're going from A to B, there's multiple cases. You could get something that looks like this. And in this case, see how the maximum, the absolute max and the absolute minimum occur at critical points where the derivative is 0. Okay, so that's one case. However, you could also have something like this, where your maximum and your minimum occur at endpoints. So you see, like, this is the absolute max, and down here is the absolute min. So that's why, like, the technique is you find the critical points. Okay, you plug the critical points into the function and plug a and b into f of x as well. That's the endpoints. And then identify the absolute max and min. Now, the one condition is, like, f of x, like needs to be continuous. All right, because if your graph has like an asymptote or something, like it could just spike up to infinity. It's not going to have a max. So here, like let's say I go through these steps. First, I find f prime. So if we call this u and this v, we'll use the product rule. So I'd have e to the x cosine x plus e to the x times minus sine x. So this is like u prime v plus u v prime. And now if I factor this, I could take out e to the x and I have cosine x minus sine x. So here's the derivative. This is all to find the critical points. Now just know this e to the x is always positive, okay? This is always positive, so you're not going to get roots from this. But cosine x minus sine x, that can equal 0 when cosine is equal to sine. You could also look for, if you divide by cosine, you could look for when tangent x, that's sine over cosine, is equal to 1. And that happens at pi over 4 and also 5 pi over 4. So trigonometry. All right, ASTC, all students take crack. So tangent of pi over 4 is 1, but also pi over 4 going this way is the same as going pi plus pi over 4, giving you this. So those are your two critical points. So if you want the absolute max, what you do is you make a table. And now you're going to plug in the endpoints, 0 and 2 pi. But you're also going to plug in pi over 4 and 5 pi over 4. So now if you plug in 0 to the original, all right, I can find that on the side. F of 0 equals e to the 0 times cosine of 0. And that's just 1 times 1. If you plug in pi over 4, this is e to the pi over 4 times cosine pi over 4, which is radical 2 over 2. So I'd have radical 2 over 2 times e to the pi over 4. All right, so that's our next one. Radical 2 over 2 times e to the pi over 4. Now, just know this is like pi over 4 is less than 1. So that's kind of like something a little bit smaller than 2 point whatever. But I don't think it's going to matter here, because if I do f of 5 pi over 4, like this is bigger than pi over 4. That's going to give us, we'll have e to the 5 pi over 4. This is a much bigger number now. Now this is like 15 over 4, which is like close to 4. And then 2.7 to almost the fourth is like a pretty big number. So here, but then we have cosine of 5 pi over 4. And that 5 pi over 4 is a quadrant 3 angle. So this is going to be negative. But you see how the reference angle, 5 pi over 4, has a reference angle of pi over 4. So this is going to be negative, but cosine of pi over 4 we already saw is root 2 over 2. And then let me make space. I'm definitely running out of space. Like, oh no, this didn't follow. All right. So now this would be times e to the 5 pi over 4. So this is like a pretty, like this number is big and then it goes pretty far negative. Okay, so it's just like going far to the left. So that's this. And then f of 2 pi equals, we would have e to the 2 pi, and we've got cosine of 2 pi. All right, this is, I think, yeah, this is definitely our biggest number here, because this is like e to like the 12th power. Let me just see real quick. Yeah, this is a pretty big number. So this is going to be 1 times, this is just e to the 2 pi. So this is looking like our absolute max. And this would be our absolute min. Okay, so that's, yeah, extreme value theorem. In a nutshell, yeah, like the fast version. All right, other questions? Let's see. Any packet requests or something to look at? Wow, we're already at 50 minutes. Time flies when you're having fun. So I don't know, was there anything earlier that I didn't get to? Oh yeah, so I guess I'll wait for the chat. Anything else you'd all like me to cover? And yeah, to anybody new just joining in, hello, and thanks for stopping by. But yeah, this is I think this is going to be interesting. I have to advertise this on social media. I was thinking maybe Reddit, because there's like an AP student subreddit, just to let them know that I'm doing weekly live streams. But what I'm probably going to wind up doing in January, I'm not going to do a calculus stream. I'm going to do it for the regents, because there's like algebra, geometry, algebra 2 regents. So I'm going to focus on those. But you're all obviously welcome to join if you want to, shout words of wisdom at the kids preparing for the regents. So let's see. Arc trig, sure. Let me see. So arc trig functions. Partial fraction, sure, we could do one of those. How about like a really challenging arc trig one? Let me see. There are some wacky ones. Let me zoom this in for a bit, because like I'm struggling for no reason. All right. I want to find one that has the arc trig function. Ooh, that one. I think that one is a nasty one. All right. Sure, I'll pick something with arc trig. So for our packet of fun people, this would be 59. Okay, if I have the integral dx over x squared plus 2x plus 10. So this one, completing the square. The thought process for these is you have to know your perfect square trinomials. That would be x squared plus 2x plus 1. Because that's x plus 1 times x plus 1. Okay, then the next one would be like x squared plus 4x plus 4. This is x plus 2 squared. And if I think of like just one more, let's say I had this. This would be x plus 3 squared. Okay, so like that's the idea. So when I look at this, all right, what I want is x squared plus 2x plus 1. But I got this extra piece here. So this I would rewrite as x squared plus 2x plus 1. And then the plus 9 I'll write at the end, because 1 plus 9 is 10. But this piece now can factor to x plus 1 squared. Okay, so that gets us here. I don't remember putting that on the test, the inverse trig. I don't remember. If I did, it won't be this crazy, but I don't think I did. I don't have the test with me. I'm like looking around as if I'm in the school, but I'm not. I'm home now. All right, so this will be dx over, and now I want to factor out a 9. So this is 9 times x plus 1 squared over 9. This is probably the weirdest bit of algebra. Like, you could kind of force this to have a GCF, even though it doesn't. The GCF is 1, but if I do factor out a 9, then that would put this thing over 9 and then plus 1. And if you're like, wait, does that work out? You could always send the 9 back through, and it's going to bring you here. So now what that allows us to do, like my thought process for this is the integral of like du over 1 plus u squared. That's tangent inverse of u. Okay, plus c. So then I could take that 1 over 9 out from the bottom. And now this is dx over, and I prefer to write the 1 first. I don't know, I'm just used to seeing it that way. And now what I'm going to call this, I'm going to call this x plus 1 over 3 to the second power. All right, I think you could all see that. If I did x plus 1 times x plus 1, that's x plus 1 squared. And then 3 squared would give me the 9. So now I'm ready to do u sub. All right, so I got to add a new page. So we'll make space. All right, and don't want to get rid of that question. So now what we have is, I would say u equals x plus 1 over 3. And just know this is like the same thing as 1/3 times x plus 1. Those are the same thing. Because then I could just say du is equal to 1/3 dx, which then tells me that 3 du equals dx. And what that allows us to do is we could take this, and now this is 1/9 integral, and we have dx is 3 du over, and this is 1 plus u squared. Okay, so that brings us here. Now this, I could take the 3 out, and I have 3/9 integral du over 1 plus u squared. So this 3 over 9 is just 1/3 tangent inverse of u and then plus c. Okay, so there it is. But then I just have to make a substitution. This is 1/3 tangent inverse of u is x plus 1 over 3, and then I tack on my plus c. All right, so that is that one. Let's double check. I hope that one is choice C. Is it? Yep, choice C, it worked. So that's a fun one. I like that algebra. It's like very, very technical. Oh, which one? Oh, so Vlad, it's possible. They could ask you to do something like that without, right? It is possible. So you want to know your trig values for sure. Yeah, it's like a commitment, but honestly, Vlad, like you can learn your trig values in like 1 or 2 days. Like one day if you really try hard. So yeah, that's, I would say, up to you. Like to master that for sure. Partial fraction decomposition. Sure, let me find one. Let me see. Where's the stars? Oh, that one is not even. All right, hang on. I think there was one. Hang on one second. I'm just trying to scroll. Yeah, this thing is like not cooperating so well. Oh, here it is. Does that? Yeah, that works. Okay. So partial fraction decomposition, 42. So if you had this, so this is like 90% algebra. Okay, so I'm going to even just say this is a side quest that we're going to go on. And for the side quest, I'm taking x minus 1 over x times x minus 2, and I'm setting this equal to some number a over x, and I'm going to leave space, plus b over some other number x minus 2. And what I'll do here, maybe I'll just copy and paste this. Oh, that Q went with it. That was a fail. All right, let's try that again. There we go. All right, copy. And I'm going to paste it here. Okay, because we'll need that again in a second. Like, meaning I want to refer to this in the original. So what I need to do is, this one needs to get multiplied by x minus 2, x minus 2. This one gets multiplied by x over x. And now once all the denominators match, you could cancel them all out. And this is going to give you x minus 1 equals a times x minus 2 plus b times x. All right, now we have to solve for a and b. And the way we're going to do that is we could plug in test values. So I would plug in something like, let's say x equals 0. Because x equals 0 will make b cancel out. And I would have 0 minus 1 equals a times 0 minus 2 plus b times 0. And this is now going to give me negative 1 equals a times negative 2 is negative 2a, which then tells me that a is equal to positive a half. All right, so that's getting the value for a. If I want to get the value for b, I'd plug in x equals 2. And plugging in x equals 2 would give me, in this equation here, this is where we're plugging in, I would get 2 minus 1 equals a times 2 minus 2. This cancels. Plus b times 2. And now I've got 1 equals 2b, which tells me b is also a half. Okay, so we got a is a half and b is a half. Sometimes that happens. Now, what we do with this information, I'm going to zoom out once more, is now this tells us, like the side quest is complete, that x minus 1 over x minus 2 is equal to a, which is a half, over x plus b, which is also a half, over x minus 2. Now, how that helps us is that when we want to evaluate this integral, now watch this, integral dx, integral dx, integral dx. Okay, this is like essentially what it allows us to do is take this complicated integral and break it up into two smaller simple integrals. Not that these are necessarily easy, but now this is 1/2 dx over x plus 1/2 dx over x minus 2. This scenario here, this one is easier. This is 1/2 ln absolute value x. And this one is 1/2 ln absolute value x minus 2, and then we throw on our plus c. We could skip u sub because, 3 dots, the derivative of x minus 2 is equal to 1. Okay, so this is just like a little side note. We don't have to do u sub because of this. If you want to do u sub, you can. It's just going to be like kind of a waste of time. So now this is 1/2, and we have ln this plus ln of this. Let me just check the answer key. Do they even do all that? Yes, they do. Okay, so this simplifies this way, and then when you have log properties, ln of a plus ln of b is ln of ab. So this would be 1/2 ln, and what we would have here, we'd have absolute value of that product, x times x minus 2 plus c. So this is looking like choice D, I hope. What number is this? 42. It's choice D, yay, it worked. Okay, so that's integration by parts. Yeah, I hope that helped. So hello to anybody who just joined. Oh, the numbers seem to be picking up here. So I'm going to take like a water break here and switch to like general Q&A. So I don't know if people got like math questions, any sort of struggles. You're struggling with confidence in math, or you're struggling with, I don't know, studying. So something like kind of light that's easy to answer. Yeah, too much talking. Definitely need a water break. So any other questions here? I know, because we got a few people here. How many we still have? Oh, there's 8 concurrent viewers right now. Very nice. Yeah, because I'm probably going to cut out soon. Yeah, 9. Although it seems to be like, it's cool because it shows me the feed of the stream. Like if I take a screenshot of this, I'll show you what it looks like on my end. It's like pretty cool. Like if let me just see. Yeah, let's get a screenshot. It tells me this. Yeah. So you see like when I first get started, there's like basically not nearly as many people here. But then, yeah, as time goes on, it like picks up. So, although this says like it's spiked down, but no, I think that's just, sometimes there's like a glitch with this thing. But otherwise, it's pretty nice to see the data. But any other questions or concerns? Because I think here, let me check the time again. Yeah, I think today I will, yeah, cut out now because I've been going for an hour and 5 minutes. But I'll say, yeah, thank you to everybody who stopped by, and to anyone who has a test, good luck, happy studying, and yeah, take care. I'll see you all later. Hopefully for week 13 if you can make it. But thank you all.